Oh, there we go. How you doing?
Hi.
How you doing?
Are you opposed to Yeah, you can log off Zoom on your phone. It's already logged into the room.
Okay.
Yeah, so you can you don't want any feedback or anything potentially. So yeah, or if you want to plug in your laptop at the bottom.
For like 5 minutes.
What?
For some time, yes.
Okay, so are you having is a second one person coming with the laptop too? Or? Okay, here we can go. Yeah, no problem. Yeah, we can go and get you set up down here. No problem. So, yes, I'm assuming you don't have the room mic, right? Mixture has.
No.
So if you don't mind just talking in here so that everyone can hear you on Zoom. Sure. So we'll go back to Tim. I'll do that up there. Yeah, if you just want to plug your you have an adapter.
USB-C?
C type.
USB-C.
Oh, okay. That won't work. That's just to do a USB or to USB. Do you have an adapter?
I don't have an adapter.
Okay. Can you?
So can I, if I log in into the Zoom and then share my screen, that would work as well, right?
Yes, but you would just have to mute. Well, let's.
Yeah, I will.
Yeah, not join on. So yeah, try to log in and then just like and then. But yeah, just make sure you're muted. So you're muted. That's fine. Yeah. And then. There you go.
That's us.
Yep.
So yeah, if you want to share your screen now. Oh, it's fine. I can. Yeah.
Only one bad thing about that picture.
What's that?
Right here. I'll be here next week. I'm
Same,
kidding.
same with you.
Which one? Sorry, what's your name? Which one are you logged in as? Or who are you?
Sadrisha.
Okay, let me see here. All right, so you should be able to share now. Be able to share?
Yeah.
Okay.
Comes up over here. Okay. Hi.
Guys on the Zoom, can you see my screen?
Yeah, so we can share. Actually, we can share on both screens.
Yeah.
Okay.
So I'll go out of Zoom real quick and then bring it up. There you go. So I'll come back. We'll come back.
Okay.
It'll flip over to that.
Yeah, it's coming back. Yeah, it should.
Oh, wait, you know what? No, that's not good. Because,
You want me to share down here? Oh, that's right. He's in Zoom. He has to share on Zoom.
yeah,
Share down here.
because you're not plugged into the room. Hold on.
Share again. All right, and let me see what he's sharing up here.
Hold on.
Excuse me. Are you guys able to download the notebook now?
It's on one screen.
Okay.
All right, you should be good. You're on one screen sharing and so everyone can see it, everyone on the far end, so yeah, you should be good.
Yep, that's perfect.
It's just on the one screen. Okay.
Yeah.
Yeah, that's good to know.
I think that's just how the room is
Yes,
set up.
that's good to know. Yes.
So, all right.
And you're recording, right?
Yep.
Okay, all right, you're all good. Just talking to the mic, you're all good to go. Oh, wait a minute, hold on. It just left.
Stop sharing.
Oh, he sounds it, okay.
No, like it disconnected, but I'll share again.
Yeah, it's better to just, instead of sharing the PowerPoint presentation, it's better to just share the whole screen, so,
Oh.
yeah.
Okay.
That's better.
Let me just do that. If it disconnects this time, I'll just share the whole
Yeah.
screen. Okay.
Can you just hit stop, okay, when you're ready?
Yep.
Go to Zoom, okay, hit stop share and then reshare it. All right, go ahead and share entire
Share
screen.
entire screen. Yep.
Okay, you have to go in and do it again. It's up.
You gotta toggle back to the screen.
You gotta go back to the Zoom app. I got you.
Yeah,
Yes.
Yeah.
Yeah, that's cool. Stay in the Zoom app. Yeah.
so actually share, don't share like, yeah, there you go. There you go.
Yep, yep.
Just don't share the Zoom app, share like your, whatever you're presenting.
Yeah, let me go down there and take a look at him too.
Yep, just,
Next week, I wanna make sure that.
no, it's working. I have to just check something on the,
Oh, okay.
Okay. And since I'm gonna be here next week, you don't mind me looking over your shoulder, I won't tell them. Trust me.
yeah, yeah.
No, unless they pay me.
So let me just create a new post here.
Hey, Sadrisha, you need to give access to the notebook for students.
Yep, that's what I'm uploading a new file.
Okay.
I'm not sure what's, so I have uploaded the file in the comments. Can you guys check if that is working for you? I apologize about this.
Yeah, I got it.
That notebook is working? Yeah, I'll just upload the same thing on the main post as well.
So actually, I just say, when you went back to the Zoom app and Zoom app presentation.
Yeah, it's weird, so to get
Yeah.
the shared view, you have to go back to display layout and that.
Yeah.
I've uploaded the main post as well.
Because it came right up after you went back.
Yeah, it's like, that's a, I don't know how they have it set up, but that's how it is, you gotta go back to that display layout for it to go in the room.
Yeah.
Because it is on the room.
So you are you saying I can't go back to any other screen if I'm sharing?
Yeah, go back, just go back to share, there you go.
There you go.
Perfect.
Okay, and then, yep.
And then you should be sharing over Zoom too.
I am sharing on the Zoom.
Zoom is sharing here, so yeah, you're good.
You're good.
Okay.
Good luck.
Thank you.
Yeah.
Hello guys, so we shall start. I hope everyone is able to access the, wait. You guys are able to download the notebook? Guys on Zoom, are you able to download the notebook? Let's put this here. Okay, sounds good. Thank you. So this lab is about CNN basics. CNNs have started, our professor has started teaching this from this week. Your homework 2 is on CNNs, so we think this will be a good starting point for implementing a basic CNN on an image data set, CIFAR 10. So this lab has 10 checkpoints, and they basically range from, it's like a pipeline, training pipeline, very basic. It's like hello world program for CNNs, you can say. Checkpoint 1 is loading the data, then it's like data processing. Checkpoint 3, you don't have to do anything. We have given you the function so that you can look at the data that you have loaded. It looks like it's a very low quality data because for this lab, we don't care about quality as such. For your homework, the quality is better than these images. This is where the meat of the code is. This is where you will implement CNNs. And keep in mind, for homeworks, we use PyTorch, but here we wanted to give you an exposure to other pretty famous package, Keras, Terraform Keras. So here you will have to implement that. And you feel free to go look at the documentation for the project, for the package. In checkpoint 5, again, oh no, here you implement your loss and your optimizer, again using TensorFlow Keras. This is where your training starts. There's this function model.fit. You should go through the hints, by the way. Like, hints are pretty effective, I feel, in this in this lab. Here you'll use something model.fit. Go check out what are its parameters, in what format does it require its parameters and everything. Get the training loss and test accuracy. So you have to finish the notebook till here. Checkpoint 8, 9, and 10, you don't have to do anything. We have given those checkpoints just for your visualizations. So for checkpoint 5, this is how our feature map after first convolution will look like. Just wanted to show you what CNN filter actually does to an image. And so so and so forth. Like, this is for first layer as well, and just some conclusion points. So go ahead, guys. Complete the notebook till checkpoint 8, and you should be good. Here we have given you a function called convolve2D. This is just basically wanted to show you how convolutions work. Let's say this is your input image. Let's imagine it only has one channel, and this is the data from a channel. And this is your filter kernel, and what convolution actually does. So if you will run this, I hope you have started with your homework to part 1. We go in detail over there about this. So basically this filter, it convolves on this array, wherein like it will first do element-wise multiplication and then sum those elements for this, and then this, and then this. And similarly, let me check what is the stride for this. Okay, it's one. Like, yeah, we are, it's gonna increment by 1. So it will return these maps. You can see the, it'll print out the, should print out the, yeah, feature map as well. And this is how the, after convolution, this is how the feature map looks like. This is just a demo to get you a feel about convolutions. Homework 2 part 1 goes much more in depth about this concept. So yeah, guys, feel free to start, and I'll be here. Just let me know if you guys have any doubts about Keras, about convolutions, or about the whole pipeline works. I will be monitoring Zoom as well. So yeah, feel free to ask questions.
I haven't started the homework 2 part 1, so it might be a little behind. But I thought kernel size is like a number, like 2, 3.
Yeah, this is called filter with a kernel size of 2 by 2.
So is it not? I am thinking for the first, like the box.
Yeah, that's what it's doing.
But why does it display one? Out of the image.
No, no, this is the, so what will actually go and pick the first, let's say these four elements? There's a filter, which is also a 2D array, and it sort of overlaps the window in this array. So this is 2 by 2, right?
Yeah.
So it like, the window in this array will be 2 by 2, and then those elements and these elements, they multiply, we do element wise multiplication and then sum them. That's how filter works, basically.
Oh,
You can picture it, right?
how do you do an element-wise location? So is this the zeros with these four elements and then what? This zeros.
No, no, like first you take 1, 2, 0, 1, 1, 2 and 0, 1, and then multiply 1 into 1, 2 into 0, 0 into 0, and 1 into minus 1, and then sum those things, and then you shift the filter by 1. So now you'll take 2, 3, 1, 2, and then do the same thing within.
Oh, and that's how you create the feature map?
Yeah. So
Oh,
this is the first thing, then this is the second thing. I'm sure that's how it works. 2, 0. Just give me 1 sec. There is something on the Zoom. Okay, guys. So let's go through a few of the checkpoints together. Let me just connect to my notebook. Oh, I'm not sharing. I hope you are able to see my screen. Yep. Okay. So this is just imports. Yeah. So CFAR 10 data set, it's available on TensorFlow. So this is how we load the data set. It gives us train images and labels and test images and labels. We can, in fact, print train image as well. Yep. It is downloading the data. So yeah, you can see this is our this is our image. There are 50,000 instances. Every instance is 32 by 32, and there are 3 channels, RGB. Same thing for test data as well, 10,000 instances, and by 32 by 32 by 3. 3 is the number of channels in the images, okay? And this is how an image looks like in this, and a corresponding label is 6 for this. So there was a question on Zoom, how do we do normalization? So for pixels, there was a hint given, I believe. Yep. The pixel values are from 0 to 255, so just divide everything by 255. So this will bring down everything in the range of 0 to 1. And as you can see here, yep, simply just divide it by 255. And if you will run this, yep, these are the images that we see, and these are the classes basically that are defined for CFAR 10 data set. So a class 6 would be dog. Yeah. I'm gonna give you few minutes to build your CNN, and let's say it's 8:40. So by 8:50, I'll give you 10 minutes to figure out your CNNs, and by 8:50 we'll start from there. I will just let me just leave my screen right there. So if you guys have anything in checkpoint 1 and checkpoint 2, take a look, or just move forward with the checkpoints, and at 8:50 we'll start from there. Thank you.
We can go into that later. I would suggest that.
I think I figured this out with this till now. So I think I
Yeah, that's what you're supposed to
multiply
do.
the column and add all the matrix.
So you are supposed to add.
The matrix, right?
No, just add all the elements. 1 minus 2. Then that will become one of it. Yeah. So that's why I said like I'll come back to it. I don't want to confuse you because.
That's just the comment. That's the camera. Everyone's, okay. Yeah. Once in a while, I'm here. I don't know. No, I won't drink that.
Whoa, whoa, whoa. Yeah.
Yeah, they're going something. Yeah, yeah. That's the way it's. That's the way it's. I'm gonna. It was like. A few of these. Yeah. That's for the other room. So, sorry, this is for this.
Yeah, I was looking at that.
Also, like, the video inputs that I gave.
Okay, so we will proceed with the implementation of CNN. Yep, so this is how we implement a CNN using TensorFlow, Keras library. So we have the inputs, shape 32 by 32 by 3, and this is how we define our first convolution layer with ReLU activation. We will name it con1, pass it the inputs, do a max pooling. In second convolution, we will have 64 output channels and or not channels, but the size. Third, we'll have 64 as well. Then we flatten everything. Here, dense means linear layer. In TensorFlow, in how in PyTorch we have linear layer, here that corresponds to dense layer. And then we will, this will act as the classification layer. And this is how the summary looks like in this. And this is, we can just compile the model like this, or I think in the notebook you can, you have to define the, yep, you have to define the loss and the optimizers. In the solutions notebook, I have just done it in the function itself. We will be using cross entropy loss for this. So you guys can take a look at the screen, see if you missed anything from this. Just give me 1 second. What's next? Okay, yeah. Yeah, okay, so take a look at the CNN, build your own CNN and proceed with the checkpoints further.
Do we need a max pooling after the third convolution block also?
No, we don't.
I think the hint on our notebook says we do.
Oh, then it's wrong. Oh. Yeah, you don't need a max pooling layer after our third convolution block. I will update the notebook.
Just checking the code we were doing tagging.
Yeah,
We are doing tagging and we are passing tagging.
after you add it and you multiply and you get a matrix, you add the elements, makes up for one of the entries of the feature.
Yeah, but I think that's still not being happened, so I'm not sure what. If you see, even if it's 0 and 0, 0 here, you know, it is 0, right? But I think I'm not sure where this 1 is coming from. Either
There's a negative one, which means this is a output location. Then to some.
these are these all So train and test in different sizes. 150, 160. Yeah, that's true. Yeah, 10,000.
Okay, guys, we'll go ahead. Um, so here, once we have loaded our loss function and optimizer and the model, um, we train the model. Let me just increase the epoch size here. Yeah, so we'll train the model for 10 epochs on train images and using train images and train labels. And for validation data, we are passing the test data set. In our homeworks, we have three partitions of the data set, train, test, train, validation, and test data. Okay, it will take some time. And then once the model is trained, we evaluate the model, we calculate the test accuracy, uh, and then just, yeah, this is just visualization steps.
Divided by 255.
The accuracy that you see here, let me just zoom in. The accuracy that you see here, I think this is after one epoch, which I ran before the lab. So let's see how much it improves if we run it for more epochs. You can see here, it's on epoch second, the accuracy increased from 55 to 60%.
Yeah.
Okay, guys, let's continue. So, after 7 epochs, our validation accuracy is not growing by that rate. It's still growing, but I feel it has plateaued. Um, and test accuracy has gone up than validation accuracy. This might hint at overfitting. If this value becomes too large, the test accuracy becomes too large, then validation accuracy. But but in our homework 2 part 2, we encourage you to train for further epochs if you see that training accuracy has reached 100% and validation accuracy is still at 60-70%. Um, because the main task over there is verification. And if you and for verification, the metric we use is EER. And if you see that EER is improving or even validation accuracy is improving, you should continue to train, even though test accuracy will reach pretty high numbers pretty quickly in early epochs. And this happens because the models are pretty large over there, so they quickly learn the data. And by learn, I mean it's like consider it sort of rote learning rather than like understanding the internal representation of the data, through which it will be able to tell apart the faces. It just memorizes the faces. Here the model is just 100,000, so small model. Even the data is also small here, but this chances of this rote learning happening is pretty common with ResNets and these large 20-30 million um, parameter models. So that's why we even in the bootcamp we encourage you to keep training for your homework to part 2 if you see that training accuracy has reached 100% and validation is behind. So let's just wait for this epoch as well. Okay, yeah. So, see, validation accuracy is not increasing. It is definitely going in the range of overfitting, because training accuracy keeps on increasing while validation has plateaued. So, I will stop the learning and go for the evaluation checkpoint. This is basically we test how well our data did on the unseen data. For this lab, this is technically not unseen data since we are using the same data set for as validation. But in real life machine learning tasks and even in our homeworks, you will have 3 different partitions in the data set. So here the test accuracy we just calculated in our last epoch, 6.902, sorry, 69.02, exactly that. Um, but yeah, the main takeaway from this checkpoint is this is how you evaluate your model in Keras. These are visualization checkpoints. So this is a technique to visualize the feature map that I think the first layer, yep, from the first convolution layers. So let me just check. Yeah. Yeah, so we take the first layer and then just get the output from the first layer and map it. So to give you an idea how what convolutions perform in an image or effect. So basically, filters. So for each layer, the idea is that each layer will find out more and more information about the image and finer information. So the idea behind first layer generally looks at broad patterns like lines, and if there are like slanting lines across the images, then these are the sort of things first layer looks at. And let's say you have an image of a flower, right? So probably by third or fourth convolution, you will start, if you will print a map like this, you will start seeing the outline of petals. If you have faces, then by third or fourth layer, you will start seeing an outline of faces. So that's how convolutions progress, finer and finer through each layer, and like more broad in the first layers. Um, this is again a visualization. I'm not sure what this is about. Let me just give me 1 second. Oh, these are filters. Okay. Yeah. So these are the filters that we have used in our three convolution layers. Um, that's how filters look like. This is just to give you an idea. Um, if we picturize them, filters and the feature map, then what does it look like? Um, and just that finishes this lab. We will be uploading this solutions notebook by end of the day, so that people who have not attended the lab, we'll give them some time to attend it, to go through the notebook themselves, and we'll be updating the material on the website by the end of the day. If you guys have any questions, feel free to ask. I will I'm here for 4 more minutes, and happy to take any questions.
I have a question about part two. I tried the 5 layers architecture, that was the basic one, and my loss kept
Okay.
and I'm guessing the low, when they said that this is the low cutoff architecture, my loss was so like my training loss went down.
Yeah.
That's good, right? Because you want your training loss somewhere in like G's and 2's, and that's
That depends from class to class. I think
no, for this for the cutoffs that we're going to be aiming for
I'm
here.
not sure. I don't remember, but I feel like this is okay.
But then the validation
Yeah,
loss
that's
is-
weird. But can you show me your logs for this? Oh, you
I have it on my file.
is the notebook on? Oh, okay.
No, I changed the other.
The ER is also on that.
Is this one is supposed to start with? It doesn't get any better.
Heap of 10 you should be. I think, I think there might be something off with the architecture. I'll have to take a look at the, come to the office. go to an office hour. I don't have an office hour this week, no?
Okay, could you have a look for like 5 minutes after the
I have a class at
class? Okay.
9:30, yeah. And I have to like go drive all the way across the campus. And
Okay, guys, we are almost out of time. Um, Hope you guys learned something about CNNs and TensorFlow. Like I mentioned, the details, the solution and recording will be available on the website by end of the day. You can compare your solutions with our solutions and see if you miss something. Feel free to edit the notebooks, play around with it. Um, that's all from this lab. Next week, we'll dive more into CNNs for the lab. Um, Hope to see you guys there. Thank you.
Just a trend for you.